Section 5.3 and 5.4, graphs of trigonometric functions. So in this class, we are only focusing on graphs of sine x, cosine x, and tangent x. So just these three functions. We will not look at the graphs of secant, cosecant, and cotangent. Now, we will also look at the transformations of sine, cosine, and tangent. So starting with graph of sine x, let's first graph it on one complete circle, like one complete unit circle, which means from in the interval 0 to 2 pi. So in order to graph this, I have taken some values here. So remember, if I draw the unit circle, this is my 0, this over here is pi over 2, this is pi, and this is 3 pi over 2 down here, and then 2 pi comes right at where the 0 is. So with these few values, 5 values basically, we will be able to graph the sine x function. So I have taken this big step to be 2 pi. So I have to put pi somewhere. Where will pi be? It will be in the middle of 2 pi, because pi is half of 2 pi. So between 0 and 2 pi, we will have pi. Then we will have pi over 2 between halfway between 0 and pi. And 3 pi over 2 will be halfway between pi and 2 pi. Now at 0, the function value is 0. At 2 pi, the function value is 0. At pi, the function value is 0. So the function we are in our table, we make sure that we add the points with the function value is 0. And then at pi over 2, the function will have a value 1, which is the highest value it will take. And then at 3 pi over 2, the value is negative 1. So I have a point here. So these 5 points we have to combine or join to make our graph. Please do not do this. Do not make straight lines and use straight lines to join these points, because this is not the graph of sine. You have to make rounded shapes. So you will make it something like this, if this is the highest point and this is like that. So this, notice that we have the function is function opens down here in this piece, opens down, or we can say it is concave down. And this, the piece between pi and 2 pi, this is concave up. I have talked about this concavity, basically means opens up, and this is open down. Okay, and so we say this is the point where the concavity changes. So it was concave down before this point. So this is called the inflection point. Now you do not really need to know these at this moment, but if you recall, previously in chapter 1 or 2, we were using this information. Okay, so I will remove this information so that our graph is nice and clear. Okay, So now this is our graph between in the interval 0 to 2 pi. So now we try to graph the piece between pi and 2 pi and 4 pi. Remember, this is 2 pi. 2 got hidden under this graph. This was 2 pi. Okay, so now 2 pi and 4 pi. What is the middle value of that? It will be 3 pi. So in the center, I have 3 pi. Half of this side will be 2 pi plus, you can find the half mid, if you recall the mid point formula. So it will be 2 pi plus 3 pi over 2. Which is 5 pi over 2. The midpoint between 3 pi and 4 pi will be 3 pi plus 4 pi over 2. That is the midpoint formula. That if you want to find the midpoint between A and B, the value of the midpoint will be A plus B over 2. So we get 7 pi over 2. So now, what is the value? Well, at 2 pi we are at 0. At 3 pi, I have the table values down here. And at 3 pi again we are at 0. At 4 pi we are at 0. At 5 pi over 2, where will we be? So at 5 pi over 2, remember counting 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So we are over here, the same place where pi over 2 is. So which means at pi over 2, remember the value is 1. So 5 pi over 2, at 5 pi over 2, the value will be 1. Then at 7 pi over 2, where are we? So we are already here. This was our 5, 6, 7. So 7 pi over 2 lands us here at 3 pi over 2. The value at 3 pi over 2 is -1. So again, we draw the piece. Okay, let me use another color. This is the highest point. There we go. Okay. Now we will try to draw it on the left. So on the left, we are looking at the interval -2 pi to 0. This is what we are looking at. Now this is also, this number is just the same length as we have from 0 till here, which is 2 pi. So we have same length over here. So this is -2 pi. So half of this will be -pi. Half of this piece will be -pi over 2. And half of this one will be -3 pi over 2. So again, finding the values at -2 pi, where are you? -2 pi means you moved on the circle, you move like this, and you arrived at -2 pi. So which means we arrived at 0. So the value is 0. What is -3 pi over 2? So -3 pi over 2 will mean we start here, we go until here. This is -3 pi over 2. The value will be 1 because it is landing us at pi over 2. At negative pi, which means you're going only half the circle, it lands you at pi, and at pi the sign is 0, so at negative pi also sign of negative pi is also 0. What do we mean by negative pi over 2? Where does it land us? Starting here, we go in the clockwise direction, so we arrive at this value point, which is the same as the 3 pi over 2. So at 3 pi over 2, the sign is negative 1. So at negative pi over 2, sign is negative 1, and then 0. So we get at negative pi over 2, value is 1. At negative pi, the value is 0. At negative 2 pi is 0. At 0 is 0. At negative pi over 2, the value is negative 1. So now, doing the same thing, we get this. So notice here that the graph, the first piece that I drew here, the portion of the graph between 0 to 2 pi. Can you see the other two pieces are exactly same? So it means the graph is repeating itself after every 2 pi. Okay, a length of 2 pi. So again, if this goes on, then it will again do this thing. And similarly on this side. And how long? It goes forever, because the domain is negative infinity to infinity. And the range you can see is negative 1 to 1. So highest point, highest value is 1, lowest value is negative 1. Or you can say highest point, you don't have to write all of them because there will be infinitely many. So you can write one of them maybe. So highest point, you can say pi over 2, comma 1. Lowest point, this one, which you can say 3 pi over 2, comma negative 1. So this is how the graph of sine will look like. Now, we'll talk about this later, but for now, from here you can see, since the graph is repeating itself after every 2 pi, so we say that it is periodic. So a function which repeats itself after a certain interval every time, it is called a periodic function, and that distance or that interval, length of the interval, is called the period of the function. So here we see, or we notice, that the function sine of x is periodic and has a period 2 pi. This is going to come later as well, so I'm not writing it. Yeah, so that is what we have. So now we can say the domain of sine x is negative infinity to infinity, and the range is negative 1 to 1, including negative 1 and 1, because it takes on the value. So it will be square bracket. So in the same way, now we will try to graph the cosine x. So we will first graph it between 0 and 2 pi. Then we will graph it from 2 pi to 4 pi. And then we will try negative 2 pi to 0. So here now, the same 5x values that I used for the sine x, but the cosine x will of course change. So at 0, the cosine x is 1. So let's say this is 1 and this is negative 1. Now notice here, I'm not going to take 1 like this because the 1 is there. The maximum value height it takes is this much. So my function is just like something like this, and this is waist, this is waist. So just be generous and take bigger intervals. So this is the negative one. Now pi is in the middle. So half of 2 pi is pi. Then we have this and we have this. So pi over 2, and this is 3 pi over 2. So at 0, the value is 1. At pi, the value is negative 1. Cosine of pi is negative 1. At 2 pi, the value is again 1. At pi over 2, the value is 0. At 3 pi over 2, the value is 0. So these 5 points, I'm going to draw the function. So notice here, this will go like this. So it's concave down here. Will be concave up here. Okay, trying to make, now it shouldn't be like coming out separately, like it shouldn't be like a something like that. It should look very smooth, as if there was no break. So this piece over here, this we say is concave down, although we don't have the whole bowl type thing, but still half the bowl down, concave down, and this is concave down over here. And this is concave down, and this one is concave up or open up, and those are open down. So this is the graph of cosine x between 0 and 2 pi. So what is the big difference between the graphs of both these functions? At 0, the graph of sine of x will start at 0 at the origin, whereas cosine x, it will start at 1 at the origin. The value will be 1. So at 0, the value of cosine is 1. Now we try to graph this next period, which is 2 pi to next interval 2 pi to 4 pi. Half 3 pi, half of this, as we did before, will be 5 pi over 2, and this was 7 pi over 2. So we look at the table values here down here, and so at 2 pi it is 1, so yes, we are at 1. And then we have to, at 5 pi over 2, the value is 0, so graph will pass through this number at this point. At 3 pi, the value is negative 1. At 7 pi over 2, the value is 0. At 4 pi, the value is 1 again. So this is, now if you don't have to stop here, you can do a little bit going like that. Okay. So now I will try to do the same thing on between the negative 2 pi and 0. First I have So now the values at negative 2 pi, the value will be 1 at negative. So remember, at any odd multiple of pi over 2, the cosine will be 0. So this is an odd multiple of pi over 2. This is an odd multiple of pi over 2, so 0. At pi, any multiple of pi, it will be negative 1. Sorry, any odd multiple of pi, it will be negative 1. At any even multiple of pi, it will be 1. So now I graph it. Same thing. So again, you see the graph is periodic with a period of 2 pi because it's repeating after every 2 pi. So once you understand how to graph the sine and cosine, then we will talk about their transformations. So again, one more time, if you are asked to graph a sine function, and let's say you are asked to graph it on its period, one period, what you should do is draw your axis, take a half the page, or at least half the page. If you take full page, it's even better. Now take a big step, so you don't have to draw on the left side, on left of the y-axis, or on the negative axis. So take a big maximum you can take the distance for the period. Put 2 pi there, whatever the period is, which in this case is 2 pi. Then go to the middle and half the period. So half of 2 pi, which is pi. Then you have this left side, left of pi, you get pi over 2. And then you have to the right of pi, and you get 3 pi over 2. And now on the y-axis, take a nice big 1, negative 1. And if it's a sine, graph of sine x, it will start at 0. At pi over 2, it will be 1, 0, 0 at the multiples of pi. And it will be negative 1 at 3 pi over 2. Something like that. Okay. So this is your graph of clean it a little bit. And it should not do this, by the way. Your graph should not look like this. Okay, this is wrong because this is a concave up here in this portion, concave down here, and then concave up again. That's not how these functions are. So it should be concave down all through until here. And then concave down, up from there. And if it's a cosine, you will start at 1 here, concave down, go to 0 at pi over, for pi over 2. Okay, not like a circle, but like a parabola, more like. At pi now, it will be negative 1. Pi, 3 pi over 2, it will be 0. And then at 2 pi it will be 1. So that will be the cosine. So this is the cosine of x, and the green one is the sine of x. So I showed you on the same axes as well. So domain here is again negative infinity to infinity, and the range is negative 1 to 1. So the domain of sine and cosine is negative infinity to infinity. The range is negative 1 to 1, including the endpoints. Okay, I'll stop here and let you guys try to practice these simple basic sine and cosine graphs. Practice these on a sheet of paper, like 2 or 3 times. Try to draw the graph of sine x and then graph of cosine x with simple these 5 points, and it will be nice if you can do it without looking at the notes. So you should know which points we are talking about. So you can do it because this is in one period. Because the period is 2 pi. So we are going only from 0 to 2 pi. Now, could we draw from negative 2 pi to 0? Yes, you could. You can draw from 2 pi to 4 pi, yes, but this makes more sense going from 0 to 2 pi. So note that the key points of the graphs of sine and cosine are the x-intercepts and the maximum and the minimum points. So if you know where the function is going to be 0, where the x-intercepts are, and when will the function have a maximum value and when will it have a minimum value, and the shape is kind of same. So you have these two kind of balls, one is like this and the other is like this, so you have to keep using them over and over again, attaching them together. Anyhow, so we'll go to next video now.